Right. So
I just screwed it up.
oh, I have to go further. Okay. All right. Well, thanks everyone for taking the time to be here today. I'm excited to be presenting some of the work that I've been working on over the last couple of years, and that sort of led me to the current project that I'm working on, and then I'll talk about that current project that specifically relates to physical activity adoption and maintenance in older adults. So before I get started though, and dig into more of the specifics of my work, I want to start by talking more broadly about the state of physical activity interventions or physical activity promotion programs. If we look at the literature, we've invested a lot of resources in trying to get people to be more physically active, especially the older adult population. However, when we look at the effectiveness of lots of those interventions or programs, typically those interventions can have sort of modest effects. And even those interventions that are really good at changing people's behavior, we often see a regression back to baseline levels or initial levels of behavior prior to the intervention over time. So we really have sort of an issue with that. Our interventions, either they're not really able to change behavior in the way that we want to, or if they do change behavior, people are not sustaining their behavior long term. And when we talk about physical activity, to reap the benefits of that behavior, it's really requires lifelong engagement in physical activity. And so there's been more of a push recently in the field of physical activity behavior change to focus on precision health initiatives. So these kinds of initiatives are focused on delivering people individualized intervention content that's going to be most helpful to that specific individual, but it's also contextualized. So it meets people where they're at in the sense of it takes into account people's physical context, social context, their moods, and how all of that might impact their willingness to engage or respond to intervention content. And because of all that, they're also timely. So we're giving people the content that they need in the context when they need it most at those specific moments. So I view the work that I've been doing over the past couple of years as trying to better position the development of these kinds of precision health initiatives, specifically just-in-time adaptive intervention, by trying to understand the time varying with in-person factors that contribute to fluctuations in health behavior. So what exactly do I mean by that? If we take a look at this graph here, what I have here is data plotted from actually one of my dissertation studies at Penn State, where we had older adults wearing an activity monitor for 14 days, and that monitor measured the time that they spent sitting each day. So in this figure here on the horizontal axis, we have the days in the study, and then on the vertical axis is the average amount of time spent sitting across those 14 days. And each colored line here represents a different person in that sample. So this is data in older adults, and you can see that this does a good job of differentiating between more and less sedentary people, right? There's some people who are sitting for only about 5 or 6 hours a day, but then there's people who are sitting for 13 hours a day, right? So we get good differentiation in terms of people's typical or usual levels of behavior. But if we look at this figure and we sort of reflect even on our own personal lives, we probably realize that our behavior is rarely this consistent, right? We're not doing the exact same amount of behavior each day. But this is typically the kind of approach we try to use to understand people's behavior, whether that's physical activity or sedentary behavior, the time people spend sitting. And so when we focus on trying to differentiate between more or less active people, we're missing a piece of the puzzle. And part of that puzzle is how people's behavior changes from day to day. And so what I have here in this figure on the right is that, again, on the horizontal axis, we have day in the study. On the vertical axis now, it's people's daily deviations from their usual level of behavior or their average level of sedentary time across the 14 days. And if people were as consistent as the figure on the left would have you believe, what we would see in the figure on the right is lots of straight lines at the 0 point on the vertical axis in the figure on the right. But that's not what we see. We see people are fluctuating around their mean levels. They have days when they're more sedentary and days when they're less sedentary than usual. Now, typically, this kind of variability that I'm showing in the figure on the right is treated as noise or meaningless. So we sort of disregard it in a lot of typical approaches that we use to studying behavior. But what my work tries to do is to capture this sort of within-person variability and try to explain it, right? Try to tap into and make meaning out of what is typically considered noise. And so the way that I try to capture this sort of variability or within-person variability is by using a methodology called ecological momentary assessment. So ecological momentary assessment, or EMA, is a real-time data capture strategy where participants are repeatedly assessed in the context of everyday life. So what does this look like? Or what does that mean? In some of the studies that I'm going to talk about today, we put an app on a smartphone, and then we lend out those smartphones, and the smartphone will prompt participants at a particular time. It could be a random time during the day. It could be based on a particular event that has happened. It could be self-initiated by a participant. And in those questionnaires on the phone, we ask them information about their current behaviors, like their physical activity and their sedentary behavior. But we also can ask them questions that we think might influence behavior or like antecedents or determinants of behavior. But we can also ask people about some of the consequences or things that we think are influenced by engagement in physical activity or sedentary behavior. And so using this kind of approach where we're giving people a device, we're asking them to go about their normal day-to-day lives and provide information on their behaviors, their context, their moods as they're going about their day-to-day lives. This type of approach helps to improve ecological validity because we're able to sort of capture that phenomenon of interest in real time as people are going about their day-to-day lives. Also, because of sort of the repeated and intensive assessments that are used in EMA, it reduces recall biases because hopefully if you've designed your study well, you're delivering those assessments or participants are getting those assessments close in time to whatever that phenomenon of interest is that you're trying to study or capture. And again, because we have these repeated and intensive assessments, we can capture the sort of temporal sequence or how these processes evolve or change over time. So in the work that I'm going to be presenting today, these studies are all going to be consistently using this kind of EMA methodology, and I'll get into some more details on that a little bit later on. And before I get into the specifics of today's presentation, I just want to sort of talk broadly about my research interests more broadly, because I know not everyone here is familiar with my work. So I'll be focusing on a sort of particular or specific aspects of it today, but using this kind of methodology, EMA, I try to better understand basically how we can use technology to both capture and intervene or capture the dynamics of behavior, motivation, and well-being, but also how to intervene on people's behavior. And then how we can, or what are the motivational processes that are both inside and outside of our awareness that are regulating our behaviors, particularly physical activity and sedentary behavior, how those behaviors impact psychological health and well-being. And then also I'm interested in work related to health behavior co-occurrence, close in time and space to one another. So for today's presentation, I'm going to more so be talking about some of the work I've done to establish the feasibility and validity of using EMA in older adults, and then from there talking about a series of work or sort of the progression of my line of research that focuses on trying to understand motivation related to behavioral adoption and maintenance in older adults. And so I just basically said that, so I'll skip over this. So in terms of some of my work related to the feasibility and validity of EMA to assess movement behaviors in older adults, when I was doing my postdoc at the University of Southern California, I was working in a research lab that specifically focused on using EMA to study physical activity behavior, but it was focusing in young children, so children and adolescents. And when we think of EMA methodology in terms of trying to better understand physical activity and sedentary behavior, that's really true of the broader literature. So most of the work that has used EMA has really focused on younger populations, and there's actually very little work trying to employ this methodology in older adults. But if you think back to that slide where I talked about all these sort of advantages of using EMA, so improving the ecological validity, being able to investigate the temporal sequence of relationships, reducing recall biases by having assessments close in time to that phenomenon of interest, you would think that you'd want to be able to make sure that if this methodology has a lot of advantages and really can help us to better understand and explain people's physical activity behavior and ultimately change it or manipulate it, that we'd want to make sure that this methodology is a useful methodology in one of our most vulnerable populations. So adults over age 60 are the least active, most sedentary, and fastest growing segment of the population. So if we think about the benefits of this kind of methodology, we want to make sure that it applies to a population like older adults if we think there's real value in studying behavior in this way. And so part of my work when I was a postdoc at the University of Southern California was focused on trying to establish the feasibility and validity of EMA, a smartphone-based EMA protocol among older adults. And so as part of the study for 10 days, we had older adults answering 6 EMA prompts per day that were randomly spaced throughout the day. And they were also wearing an active PAL activity monitor, which is what you see in the upper right-hand corner of the screen. It's a small device that's worn on the front of people's thigh, and you can actually waterproof the monitor so that people can wear it continuously. So they can wear it during the day while they're awake, when they're showering, bathing, swimming, but also when they sleep at night too. So you're able to get a lot of behavioral data from it. And so in this study, I had 104 adults over age 60 participate. I'll get into more of the specifics in a second, but one of the things that you'll notice about this population is that the sample is largely white, right? And so again, when you're thinking about the usefulness of a methodology like EMA, you want to make sure, again, that it's useful in some of our most vulnerable populations. And we know that racially and ethnically minoritized groups tend to have poorer health behavior profiles compared to their white peers. And so when I came here to UNCG, I partnered with Lori Kennedy Malone through a growth and networking event. And we designed an 8-day study, again, with 6 EMA prompts per day and wearing the active PAL activity monitor. So the 2 studies were basically identical, except one study lasted 10 days and the other study lasted 8 days. And here we only included individuals who identified as being from a racial minority group. And so we had a sample of largely individuals identifying as African-American or Black. And so I want to just go over some of the findings related to, were these older adults willing to sort of engage with the protocol? Before that, I just want to give a few more details about this. So in the study, we were loaning participants a smartphone device that had an app on it that was programmed to prompt them to answer a brief electronic questionnaire 6 times per day. They were randomly spaced between 8 a.m. and 8 p.m. So the figure that's on the screen here is a hypothetical prompting schedule for one participant for 1 day in the study. And the blue dots represent times when they would have received prompts for this one participant on this 1 day. And then additionally, during that time, as I said, we had them wearing an active PAL activity monitor on their thigh. And because the data from the phone and the activity monitor are both date and time stamped, we're able to pair those 2 data sources together and to look at how things that people report on the phone influence their future behavior, or how things that people did prior to answering a questionnaire impacted what they reported on the phone. And so just as an example of this, we can take the activity monitor data and sort of chunk it around these different prompts, or those blue dots on that timeline. So for the purposes of the data that I'm going to present, we're interested in the physical activity that happened in the 15 minutes before or after each EMA prompt. And so in terms of physical activity, we define that as time spent stepping. So walking is a common form of physical activity for older adults, both in terms of their leisure time activity and also the way that they complete activities of daily living. And so, yeah, when I talk about physical activity here, we're talking about time spent sitting. And I don't think I'm going to present any findings related to sedentary behavior, but that is basically time spent sitting in the plus or minus 15 minutes around the EMA prompt. Just to give you an example of some of the items that we were asking participants. So each EMA prompt had about 20 to 21 items in it, depending on how participants responded. That might seem like a lot, but the way the items are sort of formatted on the phone, you can see some example items here. These participants are just sort of selecting their response or dragging a dot to a point on a line, and we'll see some more examples of that later. So it's fairly easy for them to respond. Typically these kinds of questionnaires only take about 2 minutes for participants to complete. And people do get quicker at them over time because they get used to the things that we're asking them and the different ways to respond. And so in terms of are older adults sort of willing to comply with this kind of approach to studying their physical activity behaviors? In both of these studies, we found that compliance was really high. So participants were answering about 91% of the prompts that they were getting on the phone. I have the descriptive statistics here for each of the 2 studies. It's not surprising that the descriptive statistics are higher for study 1 than study 2, because remember, study 2 only lasted 8 days, but study 1 lasted 10 days. And again, in both of these samples, we were seeing compliance rates of about 91 to 92%. We also wanted to look at, using this kind of methodology, were there things that influence the likelihood of participants missing a prompt or answering a prompt? And that's important because when you're using this kind of methodology, you want to know how generalizable your data is. Are there certain sort of experiences or situations or contexts that we're not able to sample or capture with this methodology? And so we looked at a bunch of different factors, including demographic factors, and didn't find that demographic factors influenced any of the compliance factors, which is great. But we did see that participants were less likely to miss an EMA prompt, or they were more likely to answer an EMA prompt in the mornings compared to other times of the day, on weekdays compared to weekend days, and when sitting compared to times when they were not sitting. And so, again, this is just important because it speaks to sort of the generalizability of our data. And when we draw conclusions from it, sort of what might be missing, or what we might be capturing less frequently using this kind of approach. We also wanted to look at some data related to reactivity. So what I mean by that is, people sometimes worry that if you're sort of constantly asking people about their behavior or things that might be motivating their behavior, you actually change people's behavior or their motivation. And so because sort of inherent in EMA are these repeated assessments over time, we want to be able to look at behavior and see how that changes, well, in this case, right before people answered the prompt versus right after. And so here, what we're doing is we're looking at, so the item here on the screen is, what were you doing just before the phone went off? And when people selected the response option of physical activity or exercising, we categorize that occasion as them engaging in physical activity or exercise. And so we wanted to see if the physical activity in the 15 minutes before the EMA prompt differed from the 15 minutes physical activity in the 15 minutes after the EMA prompt. And essentially what we found was that there was a significant difference in behavior from before to after the prompt. But if you look at the mean numbers here, it might be a little bit different than what you would expect. People were actually slightly less active after they answered an EMA prompt and reported that they were being physically active than they were prior to answering the prompt. Typically, people are worried about, if you ask people about their behavior, they'll then engage in more of that behavior because they want to sort of engage in health promoting behaviors to make themselves sort of look good, right? But that's not what we're seeing here. If you do look at the means though, from the 15 minutes before to the 15 minutes after, so about 4 minutes to about 3.4 minutes in study 1 and 3.2 minutes to about 2.5 minutes, the differences are slight, they're less than a minute. So, you know, although it's a statistically significant difference, it may not actually amount to any sort of clinically meaningful difference in behavior. I'd be happy to talk more about what I think is going on here, but this does provide some evidence that maybe there is a little bit of reactivity in terms of people's physical activity behavior using this kind of methodology, but again, it's not in the direction that we would expect. And then the last thing that we wanted to do to really try to establish is this methodology of asking people about their behaviors through a mobile device. Is that a valid sort of approach? And so what we did was we looked at agreement between the ratings that people, or the information people were providing on the phone regarding what behavior they were engaged in, and compared that to what the device was picking up in terms of people's physical activity and sedentary behavior. And we found good agreement between these two sources of data. So on occasions when participants reported engaging in physical activity or exercise, they engaged in significantly more device-based physical activity in the plus or minus 15 minutes around the EMA prompt. And on occasions when they were reported that they were sitting during their current activity, the device picked up more sedentary behavior during that time as well. And so this sort of establishes some criterion validity. We're using sort of validated device-based measures of behavior and comparing that to what people are reporting on the phone through these intensive assessments, and we're seeing good agreement. So that's encouraging. And overall, I think that this sort of suggests that we can use this kind of methodology in older adult populations. It's feasible and valid to assess people's movement behaviors using this kind of approach. And again, one of the benefits of this is we can do this as people are going about their day-to-day lives. We're not asking them to come to a lab and tell us about what they typically do. We're able to capture their behaviors as they're going about their day-to-day lives. So I wanted to sort of move on to some work that then uses this EMA methodology to try to understand some of the motivational processes that are driving behavior in older adults. And so in my work, I use a motivational framework known as dual process theories. And so dual process theories essentially suggest that our behaviors are regulated by two different types of processes. One is reflective or more conscious processes, and the other is reactive or more automatic processes. So when we think about reflective processes, these are processes that are effortful. They require conscious deliberation and reflection. They're volitional, and they also sort of take time. So you're actively processing information about yourself, your current surroundings, your beliefs, your values. So reflective processes, these kinds of things that drive our behavior, are things like our intentions or the goals that we set, our efficacy or how confident we feel about engaging in physical activity, our knowledge or attitudes about physical activity and the benefits that we can accrue from engaging in it. Whereas reactive processes, these are things that are happening sort of unconsciously and automatically outside of our conscious awareness. So these are things that they're not taking effort, they're effortless, they're occurring really fast, and they're also unintended. So these are things like our habits. So in everyday language, we sort of talk about habits as things that we do regularly, but from a psychology perspective, habits really are the essential feature of habit is this automaticity that develops between cues in our environment and a behavioral response. And so we have these kinds of reflective or automatic processes related to physical activity. We have strong or weak habits for physical activity. And so I'm going to talk a little bit more about using this kind of general approach to understand older adults' movement behaviors, and then also some future work sort of using this kind of approach to inform interventions. So one of the first things, the idea of applying dual process models or dual process theories to explain movement behaviors is a relatively new phenomenon when we think about sort of the broader literature and trying to explain people's behavior. It's much more common to try to explain people's behavior using social cognitive frameworks like the theory of planned behavior or social cognitive theory. But dual process models are sort of emerging as a useful way to try to explain movement behaviors. And so one of the, using this kind of EMA methodology, I wanted to try to apply a dual process model to understand older adult sedentary behavior. And so in the study, we sort of used EMA to intensively sample intentions and self-efficacy. And so those are represented by these sort of repeated boxes representing sort of capturing these things repeatedly over time. And then in terms of reactive processes or these automatic processes, trying to capture habits for sedentary behavior. And so I wanted to see how both these reflective and reactive processes both sort of directly contribute to people's behavior, or specifically sedentary behavior. And so in the study I'm going to talk about, this was a 10-day EMA study with ambulatory monitoring via the ActivePal. And so at the beginning of this 10-day study, we had participants complete the self-reported behavior automaticity index, which is, it has its flaws, but it's sort of considered the gold standard for assessing habits, health behavior habits. So we asked participants questions like, sitting for extended periods of time is something I start doing before I realize I'm doing it. And so we were asking participants to complete this measure at the beginning of the study. And the reason why we only had them complete this measure once is because, as I sort of mentioned earlier, habits are really this sort of well-learned association that develops over time between cues in someone's environment and a behavioral response. So in a 10-day observational study, we would not expect habits to really change that much. And so that's why we only assessed it one time at the beginning of the study. But there's a lot of evidence in other populations that suggest that, or accumulating evidence in other populations that suggest that our intentions, so how much we're willing to try to do something, and also our self-efficacy or our beliefs about what we're capable of, they can change from day to day and also over the course of a day. And so we use this EMA protocol to try to intensively sample people's intentions and their self-efficacy. So the items that we use to assess these constructs are here on the screen. The intention item says, over the next 2 hours, I intend to limit the time I spend sitting to less than an hour and a half. And the self-efficacy item says, over the next 2 hours, I believe that I can limit the time that I spend sitting to less than an hour and a half. And we ask people's level of agreement or disagreement with those items. And so you can see sort of the mean levels of these constructs on the screen here. And then we use the ActivePal data to look at, because the items refer to people's intentions and their beliefs about their behaviors over the next 2 hours. We use data from the activity monitor that participants were wearing to look at their behavior over the next 2 hours. And here, because the item focuses specifically on limiting the time that people spend sitting, we were interested in the total minutes of sitting that they did in the 2 hours after the EMA prompt. And so here, I'm going to talk about some results from the models that we use to test these sort of relationships between intention, self-efficacy, and habit strength. One of the things I want to point out here is that in the results, you'll sort of see that for constructs that were assessed through EMA, so like intentions and self-efficacy, there are BS and WS versions of those variables. The between subject variable represents people's average level of that construct across all observations in the study, whereas the within subject variable represents people's occasion level deviations from their mean. So the between subject variable represents people's usual or typical level of that construct. The within subject represents how they're differing from their mean on that occasion. So stronger intentions or weaker intentions than normal, for example. And so in terms of the results and those reflective factors, the thing that I want to point out here is that we actually see that it's those within subject variables that are significantly related to behavior, but not people's usual levels of those constructs. So not the between subject version of those variables. And this is important because typically when we try to study motivation, we're usually very focused on capturing people's usual levels of intentions or self-efficacy. But here we're showing that it's actually not those constructs that are driving behavior. It's how people are feeling at a particular moment in time. And both of those are negatively associated. So what this says is that on occasions when people had stronger intentions or stronger self-efficacy to limit the time that they spend sitting than was typical for them, they engaged in less sedentary time on those occasions. Additionally, in terms of the reactive or automatic processes, we see that habit strength is positively associated with people's behavior. So people who tended to endorse stronger habits for sedentary behavior or had greater sort of automaticity in their sedentary behavior, they tended to engage in more sedentary behavior. So it really suggests that both these reflective and reactive processes are both contributing to behavior directly. And so this suggests that for interventions that are really focused on trying to target sedentary behavior and limit sedentary time among older adults, it's really important to enhance momentary intention formation and efficacy beliefs, but also it would be important to deliver intervention content focused on disrupting habitual sedentary behavior. So things like action planning, which are essentially really detailed plans that people make. Part of the specificity of those plans is around different contextual cues in their environment, like where they are or who they're with or what time of day it is. And so because habits sort of play such a strong role in influencing older adult sedentary time, one of the things that I was interested in, as I mentioned earlier, we use a self-reported measure to try to gauge people's automaticity. And this is a little counterintuitive because we're asking people to consciously reflect on something that may sort of unconsciously be driving their behavior. And so one of the things that I tried to do in my work is look at this idea of context dependency. So when we talk about habits and theory around habits, context dependency is really essential because habits develop over time. When you pair a contextual cue in your environment with a behavioral response, so that over time, encountering that cue becomes very well learned, almost like a schema, and that elicits that behavioral response. So when we talk about physical activity and physical activity habits or sedentary behavior habits, we should really be seeing a strong cue behavior link, but there's actually been very few studies that have tried to sort of empirically test the degree to which context dependency for behavioral engagement actually predicts habits or engagement and behavior. So using some data from the EMA study that I described earlier, we looked at participants' responses and we looked at occasions when people reported either engaging in physical activity or engaging in sedentary behavior. And we looked at additional information that they reported related to their physical context, their social context, their behavioral context, so what they were doing while they were being active or while they were sitting, and also looked at some temporal context data. So the physical context item that's on the far left portion of the screen says, where were you just before the phone went off? And there are a variety of response options that people can indicate, like indoors at home, outdoors at home. at work, outdoors, not at home, these different kinds of responses. For the social context, we asked people, where were you just before the phone went off? And they can check off as many of these as apply. So I was alone, or I was with my spouse or partner, friends, people I don't know, things like that. And then in terms of the behavioral context, for physical activity, we asked what type of physical activity or exercise people were engaging in. So we had walking, running, or jogging, bicycling, other options, things like that. And then for sitting, we asked people, were you reading, using the computer, watching movies or TV, so on. And so essentially what we did with each of these sort of contextual variables was we created entropy scores. So entropy scores really tell you about sort of either how consistent people are responding versus how inconsistent they are. And so for each of these context variables, we created these entropy scores. And then we looked at how those entropy scores, or really what they represent practically, is like a context stability score. So how stable were each of these contexts when people reported engaging in physical activity or sedentary behavior. And so these are the results for physical activity. And so here we see that there is the only significant association between one of these context stability variables and behavior, which is right here, was the physical context. So the more consistent people's physical contexts were when they were reported engaging in physical activity through the phone, the higher levels of physical activity they tended to engage in. But we didn't see that context stability was related to habits at all. And so that's sort of contrary to habit theory, right? Having greater context stability, having greater context stability should elicit stronger habits when people are engaged in physical activity behavior, but we weren't seeing that. And similarly with sedentary behavior, I'll highlight the significant findings here. In terms of the social context, the more consistent the social context, or the more stable the social context was when people reported sitting, the higher levels of sedentary behavior older adults engaged in. But the less context stability, so it's a negative association. So basically the higher the temporal context stability was, so the more consistent they engaged in sedentary behavior at a particular time of day, the lower levels of sedentary behavior overall. Or another way to think of it is the more people spaced out their sedentary behavior throughout the day, they engaged in higher levels of behavior. But again, we see this relationship with the context stability, but not, and context stability and behavior, but not with context stability and habit strength. So these results would sort of suggest that there's some type of motivational benefit, or something's happening from a motivational perspective when you engage in movement behaviors in the consistent context, but that link doesn't actually appear to be through habits, because we weren't seeing any relationships between context stability and people's habits for physical activity or sedentary behavior. So one of the things that we were sort of thinking about to try to explain these findings was that maybe it's because we included in the sample, maybe we included people who already had habits sort of well established for either physical activity or sedentary behavior. So it may be that that context dependency is really critical when you're forming habits initially, but may not be sort of that dependent once people have sort of a well-established habits. And so it really brings up the question that we really know very little about sort of how different motivational processes drive movement behaviors across the behavior change continuum. So how does people's motivation differentially impact their behavior when they're just starting out a behavior versus a behavior that they've been engaged in for a long time, when they're trying to maintain that behavior over months or years? And in addition to that sort of broader question, I think you could also say, we know very little about these with in-person processes, or when we intensively sort of sample people's behavior and their motivation, we know very little about the relationships between motivation and behavior within or across days, and particularly related to these differences between behavioral adoption versus maintenance. And so dual process theories might be particularly useful for trying to sort of explain how these different types of processes drive behavior across the behavior change continuum. So when you're initially adopting a behavior, it's possible that these sort of reflective, more conscious processes may be activated to a greater extent when you're adopting a behavior. But once you've successfully adopted that behavior and are trying to maintain that behavior long-term, successful maintenance or continued or sustained engagement in that behavior might actually be much more driven by these reactive or automatic processes. And so other people have sort of hypothesized or theorized about this. And in terms of physical activity behaviors, Alex Rothman sort of first proposed this idea almost 20 years ago. But there's actually been very little work that has sort of systematically tried to investigate this, particularly looking at these within-person associations, right? So how motivated someone is on a particular occasion and how that sort of impacts immediate subsequent behavior. And so Lori Kennedy Malone and I are, we received funding from the National Institutes on Aging to conduct a measurement burst design study with older adults, trying to look at among physical activity adopters and maintainers, how does motivation differentially contribute to behavior, physical activity behavior in this group of older adults. And so this is sort of a study is called a Move Smart. SMART stands for studying physical activity maintenance and adoption in real time. The figure here is sort of the overall layout or summary of the study. So it's a year-long study. So we're following older adults across an entire year. They participate in 3 two-week data collection periods across that year. So that's represented by these little blue boxes towards the bottom of the figure. In each of these waves or data collection periods, they last 2 weeks. So we have participants wearing an actigraph activity monitor, which is specifically designed to measure the time that people spend being physically active. And we also have them wearing an active PAL activity monitor, which is designed to measure the time they spend sitting throughout the day. So they do those things for 2 weeks. So the active PAL is sort of represented by the red line here, and the active PAL is represented by the orange line. And then for 4 days during that 2-week data collection period, they're completing an intensive EMA protocol. So that's represented by the green dots that are here on the screen. And so as part of that intensive EMA protocol, they're answering 10 prompts per day that are customized to their sleep and wake times. So the sort of pop-out box on the far right-hand side of the screen represents 1 day for one participant in the study. So it's again a hypothetical example where people are receiving those prompts randomly throughout the day. And so they repeat this over twice over a 1-year period. And so we finished data collection on this in December 2022. As you can imagine, it's a lot of data to collect from people. And so we're still working. I just had a meeting with Jeff Laban yesterday. We're sort of very close to being done, sort of harmonizing all of these data sources. But so I have some like preliminary findings related to the data from our first data collection period that I'll share with you. But don't tell Jeff because he doesn't know. So, but in terms of a little bit more detail about what we were asking people as part of the EMA protocol, we're capturing different reflective processes that are sort of just general, not behavior specific. So like we ask people about their self-efficacy, but not specific to physical activity. So right before the phone went off, I felt confident that I would be able to achieve most of the goals I set for myself. We ask about things like self-control, deliberation, their ability to sort of regulate their emotions and cope with stress. So we ask about these more general sort of reflective or conscious processes that may be associated with behavior. But then we also ask about behavior-specific reflective processes. So we ask people about their intentions to be active and limit the time that they spend sitting. their self-efficacy, and we also ask them about their plans. So the extent to which they've created detailed plans about for engaging in physical activity or limiting the time that they spend sitting. And we also ask or collect some information about different reactive processes. So we ask about affect, because people's affective experiences may sort of be one of those contextual cues that triggers behavior. We also ask about their physical and social context. And this construct here at the top about the functional stability of habits, that really gets at the extent to which people are following a routine. So sometimes it might not be a particular time of day that cues a behavior. It may actually be sort of where something falls in a sequence of events. Like I wake up, I brush my teeth, I have my coffee, then I sit for an hour and watch the news or something like that. So we're trying to sort of tap into that construct as well. And then we ask people some questions about their self-reported behavior. And again, we also have them wearing these devices during the study. And we're trying to sort of use those assessments to figure out what differentially contributes to behavior among physical activity adopters and maintainers. So we're using this sort of two-step approach to classifying physical activity adopters and maintainers. Physical activity adopters, we're saying that those are people who either are not meeting the physical activity guidelines, which is 150 minutes of moderate intensity activity per week, or they are meeting the guidelines, but they've been doing so for a short amount of time, so less than 6 months. Or they may be meeting the guidelines, but they haven't been doing it consistently each week. Whereas physical activity maintainers are people who are meeting the physical activity guidelines, and they say that they've been doing so consistently each week for at least the last 6 months. So we ask people to self-report their behavior. So this figure sort of displays the, sorry, I have some, I don't know why that's something's a little bit weird with the figure here, but that's okay. But basically, we first ask people to self-report their behavior, and based on what they self-report to us, we classify them as either a maintainer or an adopter, or they don't meet the criteria to be in the study. And then we take their activity monitor data from the 2-week data collection period, and we actually sort of check and see if for both weeks of that data collection period, the activity monitor detects them engaging in at least 150 minutes of physical activity per week for both of those weeks. And if the activity monitor detects that for both weeks, then if they were initially classified as a maintainer, then they stay classified as a maintainer. But if they initially classified themselves as a maintainer based on their self-reported data, and then the device sort of doesn't back that up, we don't see they're doing 150 minutes per week of physical activity for both of those weeks, they get classified as an adopter. And this sort of approach is important, I think, because lots of times with self-reported data, there's no perfect measure of physical activity, right? But when people self-report their behavior, they may over-report what they're doing. And so this sort of approach of trying to use two different approaches to get at people's levels of behavior can just be helpful to more sort of accurately classify people as opposed to using only one type of approach here. And so basically from our first data collection period, using that sort of initial and then back-end classification, we enrolled 129 adopters and 73 maintainers. And over the course of the study, so if you add these numbers up, we had 202 people enroll in the study, which I also just want to give a shout out to the undergraduate and graduate students that were working on this project, and I have their names listed at the end, but we started data collection in January 2021. So sort of right in the thick of COVID, and we finished data collection at the end of this past year. So we had a lot of ups and downs in terms of waves of COVID and things like that. But we were able to, when we finished the third data collection period, we had 178 older adults finish the study. So we had really excellent retention throughout the study. And that really speaks to the great job that our students were doing on the project. So I want to give them a shout out. But basically, we're trying to use this data to determine the extent to which these momentary, reflective, and reactive motivational processes are associated with subsequent physical activity and sedentary behavior, and how those might differ between behavioral adopters and maintainers. We're also, the second aim of the study is to try to look at these subject level patterns. So how stable or fluctuating people are in these reflective and reactive motivational processes, and how that might be related to whether or not people are behavioral adopters or maintainers. And then also, as an exploratory aim, we want to look at people's adopter and maintainer status from one wave to the next, and see how these different motivational processes and behavioral patterns predict whether or not people change from one wave to another in their adopter or maintainer status. And so just some quick sort of preliminary findings related to the first aim. So we were assessing things like intention, self-efficacy, and plans on the smartphone. The items are here. I already sort of went over them earlier. I have the means and standard deviations here plotted for each of these constructs for adopters and maintainers. The only I don't want to say anything because I'm not actually sure if they're significantly different or not. So I'll just say that the descriptives are here. But then we use what people were reporting related to their intentions and self-efficacy and plans, and use that to predict their physical activity over the next hour. And not surprisingly, we have lots of occasions where people were actually doing no physical activity in that 1 hour period. So about half of the observations had no physical activity. But on occasions when people did engage in at least some physical activity, the mean amount of time was about 4.5 minutes in each 1 hour period, which is not surprising for that sort of small chunk of time during the day. And we're using, the other thing I just want to point out is we're using a more stringent criteria for what physical activity is. So in some of the previous work that I presented, we talked about steps and time spent stepping. This activity is minutes of MVPA, so they have to be engaging in a particular threshold of physical activity, moderate, at least moderate intensity activity. And so because we have all this skewed data or lots of 0 points, we actually use a two-step approach to trying to model this physical activity data. In the first step, we're trying to predict the likelihood of whether or not people engaged in no physical activity or any physical activity in that 1 hour period after the prompt. And then in the second step, we're looking at occasions when people engaged in physical activity, and we're trying to predict the amount of physical activity that they engaged in. So in the results I'm going to present here, the 0 proportion on the top half of the table, that's that model where we're trying to predict the likelihood of engaging in any physical activity compared to no physical activity. And in the bottom half of the table, the positive proportion, we're trying to predict on occasions when people are active, the amount of physical activity they engaged in. And so basically what we find here is that there's this interaction with the within subject variable for intentions and the adopter or maintainer status, both in terms of the likelihood of engaging in physical activity and also the amount of physical activity that people engaged in. And so this is the results for that. The figure on the left is the likelihood of engaging in physical activity, and the figure on the right is the amount of physical activity on occasions when people engaged in physical activity. So the darker line here is the maintainers in the study, and the light gray line are the adopters. And so basically what we see here is that for both of these models, there's a stronger association between intentions and behavior for maintainers than it is adopters. And we actually see similar findings for self-efficacy and also planning, although I'm not going to present those results. So what does that mean? Well, it's actually contrary to our hypothesis, because if you remember from before, the hypothesis was that those reactive automatic processes may be activated to a greater extent when people are trying to maintain a behavior, but reflective processes may be activated to a greater extent when people are trying to adopt a behavior. But we actually found that when those reflective processes were more strongly associated with behavior among maintainers than adopters. And so I'm not going to talk about why I think that is, but we can in the question and answer period if we have time. But I just want to say that in terms of like moving forward with this data, I talked about at the beginning how we typically try to focus on usual levels of people's behavior and trying to predict what differentiates more or less active people overall. But we can use this kind of intensive data with computational modeling to help develop dynamic theoretical models that take into account more information about the context that people are in, how motivation changes across time and information like that. And so that's really what I want to sort of try to do next with all of this data that we've collected once we address the specific aims of that project, is to try to develop this more dynamic model for explaining people's physical activity behavior. And so I started the talk today sort of presenting these two different figures and saying how we typically focus a lot more on the figure on the left and trying to differentiate more or less sedentary or active people, but that we typically ignore a lot of the variability in people's behavior from day to day or moment to moment, which you see in the figure on the right. So hopefully I've at least started to convince you today that we can learn a lot of important information by trying to tap into people's day-to-day or moment-to-moment variability in their behavior. And if we continue to do that and learn more about what drives those changes in behavior from moment to moment or day to day, it can help us to develop more effective interventions that not only get people to change their behavior initially, but then also sustain that behavior long-term. So I just want to thank everybody for coming today and listening to some of the work that we've been doing over the last couple of years. I already gave a shout out to Lori, but I also want to acknowledge lots of the graduate and undergraduate students that have been really essential in this work. Because without them and the people who are providing funding for this work, it wouldn't be possible. So thanks for your time today. And I know I have to run in a little bit, but I can stay around for a couple of questions if people have them.
I am going to stop recording real quick.